Let's work out this example. So we have the limit as x approaches 4, and then in the numerator we have the square root of x plus 5 minus 3, and in the denominator we have x minus 4. So the rule is if you can plug in the number and you get an answer, go for it. But as you can see, if we plug in 4 here on the bottom, we end up getting 0 on the bottom because 4 minus 4 is 0. So we need to do something else. So that something else is called rationalizing. I'm going to show you how to do that. So we'll start by writing down the problem again. So we have the limit as x approaches 4. And then we have this piece here. So the square root of x plus 5 minus 3. And it's all over x minus 4. Remember, it's really important to always write the limit sign until you take the limit. And then what we're going to do is we're going to multiply by 1 in a very, very clever way. So we're going to multiply by the conjugate like this. Parentheses, square root, x plus 5. And then you just switch the sign here, so make it a plus. And then you can't just multiply by this, right? So it's wrong. So the trick is you divide by it as well. So we get the square root of x plus 5 plus 3. All right, and then now we're going to invoke a very, very powerful formula. This is a formula called the difference of squares formula. It says if you have a minus b times a plus b, this is equal to a squared minus b squared. So our a in this problem is the square root of x plus 5, and our b is 3. So this will be equal to, this is all equal, the limit as x approaches 4. And then it's just going to be a squared minus b squared in the numerator. So when you square this square root, it's going to go away. So we're just going to get x plus 5. And then minus, and then b squared, but we said b is 3, so minus 9. All divided by, we still have the x minus 4 here. And you want to be really careful. I've messed this up before in the past myself. You want to not forget this bottom piece here, square root x plus 5 plus 3. Very nice. So this is equal to the limit as x approaches 4. So 5 minus 9 is minus 4. So this is x minus 4 over, and then down here we have x minus 4, and then square root x plus 5, and then plus 3, plus 3. All right, so all looks good. Again, we saw the original question. Let me just do a little quick recap for you. And the reason you know to do this, by the way, is because whenever you have like a square root like this and you're adding or subtracting a number, you want to invoke this technique. This technique is called rationalizing the numerator. Okay, rationalizing the numerator. So we're rationalizing the numerator, and you do that by multiplying by the conjugate. You just change the sign and then divide by it, and then just use the difference of squares formula. We get here. Be really careful on the bottom. You definitely want to have that piece there. It's easy to forget it. And then you get to this point here. Now this is where the magic happens. These cancel. So this is the limit as x approaches 4. And then we're just left with a 1 up top, which is cool. So 1 over. And then we have on the bottom here the square root of x plus 5 plus 3. And now we've finally reached a point where we can actually plug in the limit. So plug in the number rather. So we're plugging in the number into this expression. So we drop the limit sign. So we have 1 over the square root of 4 plus 5 plus 3. So we plug in the number into our function here. And this is equal to 1 over 4 plus 5 is 9. So you get the square root of 9 plus 3. And square root of 9 is 3. So this is 1 over 3 plus 3. This is 1 over 6. And so that would be the answer